A very warm welcome to the Holland High Tech Network event 2026. Lukas Ziegler is with us, and one could say that he is Europe's leading voice on industrial and cognitive robotics. But I must tell you that it was never his plan to become a robotics influencer or an evangelist even. That's what people call you, Lukas. Because he started in coding. That's what you did, and then shifted from coding towards explaining robotics. And since 2018, so that's quite some years now, but he has visited over 150 robotic companies. He is a Forbes 30 under 30 honoree, keynote speaker at the United Nations AI for Good Summit, but also at the Hannover Messe, combining market insight, startup experience, and a strong ability to translate emerging technologies, what we are talking about today, into that strategic relevance. His focus, dear all, sits where industrial robotics meets cognitive capabilities, so machines that perceive, that reason, machines that adapt, reshaping manufacturing, reshaping logistics, and high-tech production. So, Lukas, it's wonderful to have you here. I'm going to welcome you to the stage, and I'm going to ask you this very important question: why exactly do we need to accelerate here? Ladies and gentlemen, Lukas Ziegler.
Thank you so much.
Floor is yours.
Thank you. Thank you so much. It's a great pleasure and a big privilege to be here amongst so many great technological, political figures. I'm just a humble guy, super obsessed and passionate about robots. I will tell about what are my observations and when the robotics might be heading. So to understand where the robotics is going, I think truly that we need to understand where exactly is it right now. And as we know, the AI is a big catalyst pushing robotics forward. So today, let's just zoom out a little bit and let's check where the robotics 2.0, or how we like to call it, the cognitive robotics, which is robotics that can sense, that can reason, that is smarter than it used to be. And let me take you for a very short journey. I just also wanted to share agenda what I'm going to be talking about. First of all, why robotics now? I know that there is so many great industrialists among us, but just so everyone have the same level of awareness, I will give you a couple of extraordinary arguments why robotics matters just now. Then I will cover the topic of cognitive robotics in detail and why are we closer to that than ever. Breakthroughs that make it happen, and what's next? What are the opportunities and what are the chances of that? So just a little bit about myself. I used to deploy robots all around the world, different ones. Firstly, robot arms, cobots, mobile robots, quadrupeds, which are the robot dogs, even here in Netherlands with Shell. I also tried to deploy humanoids. Back then, it wasn't ready. Let's see if they are ready today. That's also one of the answers I would love to give, or have a brainstorming sessions with you, because as you know, there's going to be a Q&A, so very happy to take a lot of questions from you. As I was already introduced, I like to call myself a robotics evangelist, which basically means that I love to talk about robots whenever and wherever I am. Also during the family gatherings, probably that's why I'm no longer invited to those. But yeah, nevertheless, I managed to gather quite a big community on Twitter, LinkedIn, my newsletters, more than 500,000 followers in total, 300 million views in total just for robotics. I think it also shows that physical AI / robotics / embodied AI is not just a DIY thing for nerds, but it's actually becoming a really, really important topic, recognized by investors, young engineers, and institutional entities. So yeah, let me just go and start with the very, very, very easy claim that everyone is using AI these days, and people cannot live without it, even though we are just 4 years after getting the commoditized AI for literally everyone that has a smartphone. And we do plenty of things. We plan our travels, we ask for recommendations. Right now we do research in seconds. We do coding, we can build our website right now in the blink of an eye. So it's fair to say that it literally has changed our personal lives, but also business lives. But it's purely digital, right? It's about interacting with the digital world, about words. It's not about the hard thing, so interacting about the physical world. And as the most famous leather jacket man, which is the CEO of NVIDIA, said, that the holy grail of the AI race will be the physical AI, because it's the hardest one to solve, but it's also the one that is the most meaningful to us people, that will replace the yeah, a lot of effort in the physical activities. That's why I officially believe that AI needs a body. And I think that a lot of people here will agree that the perfect embodiment for AI are robots. So let me focus on a couple of arguments why robotics right now. I truly believe that almost every person here is fully aware that we are, considering robotics as an interesting topic in the innovation, but still, let me give you a couple of arguments why. I think we are living through a really historic shift where the human labor is truly a luxury. Probably first time in the age of humanity. Production is up, logistics is up, demand is up, expectations of the end customers also are up. So something needs to fill that gap, and I believe that this something is robotics. Let's start with the first fact. Obviously the most common, so when it comes to demographic shift. So there is a slow-moving crisis unfolding across Europe that doesn't make daily headlines, but it shapes everything. So birth rates have fallen to 1.5 per woman, and just to give a little bit of clarification on how United Nations is defining that, they have quite a funny anecdote how to check if we are in a healthy ratio. Would be good to have the fertility rate, so how many babies per woman at the level of 2.2. And there is a good argument for that, 1 per mommy, 1 per daddy, and 0.2 for the sake of healthy economy. We don't have that. So I'm going to ask a very rhetorical question. Do you think that we want to order less things, or we want to produce less things? Actually, it's quite the opposite. We still want to have the package being delivered tomorrow, and we are itching ourselves if the package is not actually at our door, right? So to really, really meet that demand, we need something that is much more efficient than us humans and much more reliable than us humans. So that's one of the arguments I wanted to make. Second, if this becomes true and we're going to have a lot of robots, we need to have a group of people that will take care of those. And according to McKinsey, there will be more than 1 million engineers missing in the US, more than 100,000 in Germany, just in 4 years. So that's the technical foundation, technical bedrock that we need to have in order to have technology replacing our manual labor. Because as we know, we need to service it, we need to maintain it, someone needs to take care when there is any anomaly happening with that machine. So that's another point I wanted to make. So we need technical foundation to be kept there. And right now, last point I decided to do, I could have much more arguments, it's this one. So $7 trillion, I'm gonna repeat it again, it's not billion, it's $7 trillion. This is where e-commerce market, the global e-commerce market headed in 2025. And I truly believe that every single dollar out of this lump sum is represented by a package that needs to be checked, needs to be sorted, needs to be sent, and needs to be delivered in a crazy time, because we have our expectations and we order really, really all the time. So automation doesn't just help here, it's crucial, and I think it's the only thing that keeps us up to the demand and keeps us from this whole system collapsing under its own weight. So those were the arguments, and right now, just to make it more interactive, I want you to fasten your seatbelts. We're gonna jump into our time travel machine and we're gonna go back 60 years. Just to show you one of the first, there is a lot of arguments which robots was the first. Let's assume Unimate was one of the first robots on the market with the digital system. So back in the days, it was already super precise and repeatable, which allowed the industrialists to install it in the different factories to make very mundane and repetitive tasks with a great accuracy and with a great repetition. So General Motors put it first to handling the heavy and repetitive tasks, as I mentioned before. Then, after they saw a huge success in those machines, they started to spread it across different US plants, and then later globally. Why I'm showing it? I'm just showing that the robot revolution 1.0 didn't start when there was talking about AI. It's already started more than 70 years ago. So that's one thing. And right now, again, we go forth in time, and I wanted to show you that we already have some, even yesterday Hexagon announced the successful deployment of a pilot in a BMW in Leipzig, and it was a humanoid dealing with some pick and place tasks. So that's where we are right now. So humanoids, robots, machines that move, adapt, just like us, are already on the job. I know there is a lot of questions about the productivity and why they should look like human, maybe they shouldn't look like human. We're gonna cover it in a dedicated session about humanoids, but just wanted to flag it that those robots are already starting to being deployed in the industries. So it's not just in the demos, in the labs. So what took really decades to crawl, it looks like it's just sprinting in a matter of months, also by the very big push of AI. So we can have different names for the revolution, that robotics 2.0 or cognitive robotics is really, or the smart robot, but just wanted to welcome you, in my opinion, to the new era of robotics 2.0. And you know, taking everything what I see happening in the physical AI space, by the way, physical AI space is right now a very trendy way of saying robotics, if someone doesn't know. But you know, there are humanoids, there are world models, there are companies literally spawning every day to collect data, to fill those models with world data, because robots don't accept text. They would prefer to have multimodal data from the world that is actually around us. So yeah, I think it's safe to say that we are no longer approaching it, but we have just entered a new era that I'm super excited to talk about. So let's look at this slide and let that sink in, that Robot 1.0 was all about the fixed control, fixed sensors, fixed programs. It was very hard to reprogram a robot once you have deployed it. And the Robotics 2.0 is all about the intelligence. So robots that are learning from data, finding patterns, adapting, operating in different environments that they even haven't seen before. In the Robotics 1.0, we were teaching the robot. In the Robotics 2.0, we expect the robot to learn itself. And yeah, I saw some opportunities, especially after my travels recently to the United States. I started to ask the Frontier AI labs, like, how do they see the system integrator transformation? And for those who don't know, system integrators are the great technological innovative companies that are installing robots, maintaining them, servicing them, making sure that they are really adding value in manufacturing, logistics, in other industries. But yeah, here just wanted also to show that there is quite a good opportunity behind it, because system integrators are right now the facing entity when it comes to clients. So you have the direct approach to the clients, and right now it's all about the data. So there is like an almost infinite amount of data that you can get out of these deployments. So that's one of these. And here is the playbook. So there are a couple of things that are enabling us to get more data. First of all, teleoperation. So even if there are tasks that cannot be yet fully automated, you can gather that data manually, you can teleoperate it and already start accomplishing some tasks fully remotely. And then actually with the data flywheel start to enabling it more into autonomy. With the dream of having zero-shot deployment, which means that you have literally no data and you're able to accomplish any task with a robot. So that's how I also see, after speaking to many of those industrialists, how we can transform really the integrator models here and how the data can help us to be even closer to the customers and develop new models out here. But robot arms and humanoids are not the only form factors that you can see in robotics. So also wanted to show a couple of different markets that are in robotics right now. And it's a little bit connected also to the technical foundation of the people missing in those industries like oil and gas, energy, chemical. So right now I wanted to show you inspection robots that are autonomous or teleoperated robots dedicated to inspect and maintain these critical industries fully autonomously or via teleoperation if there is such a need. So they don't just see, but they can also smell. They can also detect anomalies. Let me start with the first one that is called the European Boston Dynamics that everyone knows. It's called Anybotics. And Animal is the quadruped robot X-proof, which is 8X certified, that can go into these dangerous environments and do the inspections for humans. So it has a fixed route and is able to collect multiple data points, feeding up to the software systems fully digitally, and also doing the AI recognition of the assets that it's taking the pictures from. So I think it matters also for the business, because first you have safer workers, but you also have something that is constantly checking the infrastructure that, as I mentioned before, is really critical to that. So that's one of the examples. Second, we already know that robots are not just about the hardware, robots are also about the software, and I think Gecko Robotics has cracked the code by combining wall climbing robots with enterprise level of software. where they are just gathering data from their critical infrastructure here, like storage tanks, but also vessels, and transforming those into business insights and feeding them later their systems. So smarter hardware in this case means even smarter software. It also shows that in the AI revolution, it's not just about the welded parts, but it's also about the lines of code that are coming into it. And when we speak about inspection robots, we've already touched oil and gas. We've already touched the shipyard industry. I also wanted to touch something that manufacturing knows, logistics knows, because everyone has the security guards. And this is a project from Ascento. So it's an autonomous two-wheeled system that is able to patrol all the spaces fully autonomously and check if any gates are opened, check if there are no intruders, check what kind of license plates of the cars are parked in the parking, if there are no holes in the fences. Literally just to have something that is constantly monitoring our asset, especially considering we are missing out of the labor that is doing this. A bit. Just a sip. And let's also reinvent the wheel, or perhaps let's reinvent the arm, because we know that arms for more than 70 years, but right now there is much more use cases that we see those arms being used for. And I also wanted to present some of them. There is literally every week there is a new paper, there is a new application for that, but let's start first of all with the truck loading. So the robot is literally playing a Tetris here in real life, making sure that the boxes can be put inside of the ships. Even Boston Dynamics right now have a similar solution. This is actually Dexterity from San Francisco, that is literally coming with a conveyor inside the truck and is building a box walls in real time to make sure that we can fit as much as possible. So that's one of the usage that we can also see here. Then a use case from the UK in an industry that is also quite hard to find people, which is meant to preempt the conveyor in a recycling space. So this system literally transforms images of recyclable materials into pixels, into data, digitizing pixels and classifying them by different materials like metal or cardboard, aluminum, so just human workers have much easier job to do later. Last but not least, more like a fun example from Cambridge, when we have a robot chef that can watch the videos of chef cooking and can extrapolate from that the full recipe and all the ingredients inside. I think it's also a good example of showing that video footage is a really, really valuable material for robots, that robots can learn from and extract data, so they can become later more adaptive and do more tasks on their own. Supposedly the rate was 93%, and if you're gonna see the dish itself, I think we are still quite safe when it comes to cooking, at least. But yeah, this is how the perception of the robot is able to detect different parts and recreate the different dishes also. Okay. And yeah, I think right now it's time for the humanoids. There is a lot of hype about them. There is right now much more awareness, but there is also a lot of questions. Why do we even need humanoids? Do the humanoids should have wheels? Should they have legs? Why do we need them if we already have like a really high performance systems in across different industries? There is a couple of different answers from different angles. Some people claim that we want to have humanoids because they are able to retrofit our manufacturing and logistics facilities. Some of people say that, yeah, we want to have humanoids at houses. This is quite a bold statement, because if we do a survey, how many people would love to have something that weighs 60 kilograms is a robot that you cannot trust that much? Would you like to have it in your apartment or house? So very mixed opinions. But there is a bold promise behind it. And right now there are two different approaches. First approach is master one task like no one else, and then go horizontally from there. So here is the pattern that actually most commercially successful robots companies are doing right now. I presented the agility robotics and persona AI. So agility robotics is fully focusing on creating a robot for a very handful set of tasks in intralogistics. And it's all about moving totes. They can pick them up, they can place them on the conveyors, they can place them on the mobile robots, but they are doing one task, but at an excellent level. And then they want to horizontally expand to different tasks. And the same thing actually comes to Persona AI. So Persona AI started to work with on a humanoid for very heavy industry tasks, like for example, industrial welding at shipyards. So they partnered up with Hyundai HD to make the welding possible with the humanoid robot. But instead of talking to the innovation people at Hyundai HD, they started to talking to their best system integrator company, just to get all the insights and the biggest know-how they can, to make sure that they can fine-tune the robot and actually make it be excellent at welding at the shipyards. So the strategy here is simple: start with one task and then horizontally expand to different tasks that are similar to the first one. And obviously, when we see all the dancing robots doing show, because everyone saw a dancing humanoid, or if you go to an industrial trade show, you see all these Chinese robotics doing different stuff. This is the promise of, obviously, companies like Figure or Tesla, where they want to do a robot that is able to do generally any task you can give it. So there is a bigger price, but also the journey to that is much more complex and complicated. To make one robot that is able to do your dishwashing, to do an industrial task, to do something in logistics, this is just much more a melody of a future, to have a very generalistic robot that is able to tackle as many tasks as we can just imagine. So majority of the capital right now, also in the venture space, when it comes to humanoids, have this promise in their head that, hey, we're going to have a robot that is going to be like the Rosie the robot in Jetsons. It's going to do majority of the tasks we can imagine. And just to show some breakthrough, this is actually a video from Boston Dynamics Atlas, new version from 2 months ago. This is no CGI, because I know there is like a big thing with the, a lot of AI-generated content done for robots. Here you can see what the robots are capable from the athletic point of view. And then someone's going to ask, okay, but why do we need a robot that can do cartwheels when there's a robot that is actually supposed to work in the industrial side? And yeah, that's a good point. I don't think it needs to do cartwheels. It's just to show the progress and what are the possibilities right now with the robots. Here's, for example, a home robot, a Sunday Robotics, with quite a unique approach of collecting data by the end user. So imagine that, we know that the robots aren't perfect, but we want to teach the robot to, to pick up a glass that it hasn't seen before, or it has a slightly different shape than a regular one. So you have an interface developed in Stanford where you can teach your robot with a smart glove to collect the data for the robot, so the robot can train faster and be more efficient and more successful in order to make tasks. So I visited this company, and their approach is to ship a couple of thousand still this year. For obviously, if you are selling something that innovative, you always start with the users that are super optimistic about the technology, because they are going to be your evangelists when it comes to the next wave. So yeah. That's when it comes to showing what's possible when it comes to industrial robots, like with Boston Dynamics, but also household robots, as you can see here. Last but not least, a couple of breakthroughs that I wanted to showcase that are pushing a little bit the development here in robotics, from what I've noticed traveling around the globe. So we all know that AI is pushing robotics forward at an incredible pace, and I prepared three developments. First of them is the cross-embodiment. Cross-embodiment means that you're creating a single robot brain for different robot form factors, different robot types. So you can have a robot brain that can control the humanoid, can control a robot dog, potentially can control a mobile base with a couple of arms on it. And companies like Skilled AI are actually making this possible by creating, let's say, one unified software to control all different types of robots, just to make them easier to deploy, reskill, or reprogram. So we've seen already Unitree dog, Unitree humanoid. Here we have Franca and Mika arms. So that's first, cross-embodiment. So just have one policy to train different robots. Second, it's dexterous manipulation, but from actually two angles, hardware and software, because tasks we take for granted, like tying our shoelaces or doing something dexterous in industrial setup, are quite easy for humans, for us, quite natural, but they are very complex for machines. That's why here I wanted to show one policy developed at Stanford that with very few demonstrations, you have a capable robot hand doing different tasks with very few demonstrations. There will be always questions about the efficiency. Right now, I think we are at the stage that we are able to show cool demos, but it's also the matter of data, and it's a matter of a couple of research breakthroughs that we are, away from having robots that can be deployed across the industries. Yeah. I think we are safe from the art side. Yeah, and the last but not least, seem too real. So yeah, the gap between simulation and reality has been truly also a bottleneck. So whatever you put into simulation, it was not always like this when you deployed it in a real robot. So domain randomization here is closing it. So imagine that you can predict a lot of environments, a lot of scenarios, situations for the robot already in the situation. So once you deploy it to the real robot, it already knows, it already learned something in the simulation in a lot of scenarios. And yeah, I think for years the robotics progress felt incremental to some degree, one robot, one use case, one application. But then we noticed something that and a lot of arguments are telling that it might be true, if we apply the same nominals here, like compute and data, this means that actually the evidence says so. We are actually at the beginning of the exponential curve when it comes to robotics learning and robotics deployment. So let's hope for that. And yeah, what to do to scale up the robotics deployment? There is a couple of things I noted. What is worth right now working on, like deployment distribution data. So making sure that we get this industrial data. We have a lot of in-lab, we have a lot of demo sessions, but we are still missing the real industrial data. That's why I think it's really, really important to have system integrators also somehow be plugged in to these physical AI revolution to provide that industrialized data that might add additional context for robots. Reliability engineering. Deploying a robot in a lab is not the same as deploying it on a production floor, so I think we need to really be very, very careful when it comes to safety and all these related to that things. Edge deployment models, I think we've also covered that a little bit before, that robots require almost real-time actions, and once you connect it to cloud, might be too late to react to something. That's why it's also the matter to create edge deployable models, so it's lightweight enough to be deployed on the edge, but also capable enough to run the latest policies for the robots. And integration infrastructure. So four things that will define it. And there is a very famous robotics director at NVIDIA, Jim Fan, that said, I think 2 weeks ago in SF on a Sequoia meeting called AI Ascent, that very cool quote that I decided also to share with you, that we are a generation that was born too late to explore the Earth. We are the generation that was explored a bit too early to explore the stars, but we are a generation that was born just in time to solve robotics, and that's what I'm wishing for all of us. So yeah, that's it. Thank you so much for this, and very happy to take questions.